Disorderly conduct. Okay, so on your unit exam, let's get started. On your unit exam, there will be a vocabulary question. Okay, I promise you there will be. It may be where you take two terms and I'm going to ask you to compare them and tell me the differences and similarities. It might be that I just ask you to define it and draw a picture. Okay, there will be vocabulary on your unit exam, so be prepared for that. So let's start with a relation. What is a relation? Well, what's the root word of relation? Ryan Wayne? Relate. Relate. Okay, so in terms of mathematics, let's think of it in terms of graphing, x and y. There's some sort of relationship that connects our x and y together. There's some sort of association there. So the relation is association, associates the elements from one set, associates the elements of one set to the elements of another set. So it's the connection between two things. Some sort of connection between two sets of numbers. Okay, so what's a function? What's the root word of function? Fun. Fun, 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 fun. Okay. Okay, so what is a function? Well, function is a type of relation, a special type of relation. It's a fun relation. Okay, a special type of relation that, well, in order to continue on with this definition, I have to give you another definition before we write anything else. So let's go down to domain and range. Okay, so what is domain? I'm going to tell you right now. Domain is the element in the first set. The element in the first set. So it's associated with X. Range? Want to take a guess?
The second set.
Yeah, the element in the second set. So it's associated with who? The Y. Because it is. Definition, vocabulary. Okay, so we have, say I was comparing time and distance. Something we just looked at in the previous lesson. 0, 0, 1, 100, 2, 200, and so forth. So domain would be the actual elements. So 0, 1, 2 of the first set. 0, 100, 200 would be called the range, the elements of the second set. Now, which one would be X here? Time. The first one is always your X. The second in a chart is always Y. Okay. Now, time and distance actually have another name as well. But we're going to come back to that. So let's go back to function, what a function is. So now that we know the domain is the elements in the first set and range is the elements in the second set. Okay. No, a function is not 3 sets. It's a special type of relation where each element in the domain, Caleb, front, thank you. Each element in the domain, so that's the first set, each element in the first set is associated only one element in the range. Only one element in the range. So in other words, each input has only one output. Each input, or X, has only one Y output. Each X has only one Y. So for example, in our example of time, at 1 hour, we can't be at two different distances. So it's a function, right? Each input has only one output. So we'll look at a few examples today and tomorrow of what a domain is and what a domain isn't. But basically the concept, I have it on the board on the side here. If you have distance over time, we had the chart 0, 0, 1, 100, 2, 100. Is that possible? So at 0, 0, at 1 hour, we're at 100, and then at 2 hours, we're also at 100. Yeah. Each X has its own Y. So each X has its own Y. That is a function, okay? An example of something that's not a function is what if we had the situation instead, so distance and time, or sorry, time and distance. So we had 0, 0 again, 1, 100, 1, 200. So at 1 hour, can you be at two different distances? No, that's not a function. That's not a function because the element in the domain, the element of one has two outputs. One has the output of 100 and 200. There should only be one output for each input. Okay, so we'll get into that in more detail. All right, so what's the independent variable? At 1 point. You can't be at two places. Okay, independent variable is the variable of the x variable. And the dependent is the y variable. So if you had a graph, kind of like science, manipulated responding, right? So we say y depends on x. That's why y is the dependent. Whoa, tongue twister. So dependent is our y. It's always on the vertical, and independent is on the horizontal. Which is why, here we go again, time is always independent. Time is always, you can't get something that's going to produce, like that you're responding, your dependent is time. Time is always independent, and then distance or speed is your dependent. Okay, so on our chart down below, what's time here? Independent variable. So what's here? This would be the independent variable, time. And what's y? Then the distance would be the dependent variable. The distance depends on how long I traveled, my time. My distance depends on my time. All right, two more terms. Discrete and continuous. I'm going to draw a graph, a little picture first, and then we'll describe it. All right, so continuous is kind of simple. Here's an example of continuous. Here's an example of discrete. You talked about discrete and continuous before? Oh, good. That's good. Okay. So what is discrete? What's continuous data? Well, continuous data can be drawn continually, right? It's connected data that's connected. Not a pattern necessarily that repeats. It doesn't necessarily have to have a pattern. It's just things that are real numbers. So data that's, instead of, you can also think of it as data that's real numbers. All real numbers. So decimals, fractions, irrational, rational. So an example of continuous data is time. Time is continuous, right? You can have half of a second, 0.25 of a second, 1/13 of a second. That's another example of continuous data. Distance. Money can be continuous. It could also be discrete, depending on the situation. Okay, so discrete data then, if continuous can be connected, and discrete cannot be. So it's not real numbers, data that does not have real numbers. Usually it's natural numbers, counting numbers. So cannot be connected. So it's usually like natural numbers, data that has natural numbers. Usually, not always. So some examples of that are usually situations that are counting situations, like number of people, number of tickets. It doesn't always have to be number of, right? And why is number of people discrete? Can't have half of a person. You can't have half of a ticket. You either have it or you don't. Okay, there's an examples that are money and time can be discrete. If I'm doing a parking meter and I pay $1 for up to an hour of parking. So if I'm parking for, so that graph is really cool actually. It looks like this. It's called a step function. Actually, I wouldn't have the little line. It looked like this. Okay, it's literally a step. So if I was graphing the dollars you pay versus over time at a parking meter, why would that graph look like this? Well, if I park, yeah, Simone? Yeah, McLean?
There's no like in the middle of the line, so it can't have a line going from there to there because there's.
Right. So if I park for half an hour, if I'm paying $1 for every hour, let's say. If I park for half an hour, how much do I pay? No. You pay $1. Anytime from 0 to 59 minutes, I pay $1. Right? And then the 2-hour interval, I pay $2. It doesn't matter if I'm there for an hour and 1 minute or an hour and 59 minutes. I still pay $2. So that's an example of a step function, and that would be discrete data, right? Why? A continuous function, you basically, the real definition of continuous, you're going to love this, is basically that you can draw it without lifting your pencil. That is the real definition, the actual mathematical definition. You can draw it without, literally, you can draw it without lifting your pencil. So is that continuous? No, I'd have to lift my pencil to draw the other steps, so that would be discrete, right? Okay. No. Okay. Turn the page. Let's look at one example, and then we're done for this lesson, this part of the lesson. So, example 1. Color versus fruit and fruit versus color. How are these relations similar? How are these relations similar? So how are they the same? Just how are they? Same elements. They have the same elements. They both involve fruit and color. How are they different then? How are they different? They're reversed. So what do we call the elements of the first? What are they called? Those are the domain. And what are these guys called? The range. So we could say the domain and ranged are switched. Domain and range. Or you could even say the independent variable and dependent variable. That's you could say that too. Are switched. Write relation to as a set of ordered pairs. Okay, first thing is we need to talk about set brackets. Set brackets look like this. Okay, ordered pair brackets. Now, if you are horrible at set brackets, which some of you are, I do recognize that they take a little bit of practice, which you have the whole unit to practice. I will let you get away with that.
Yes.
Okay? However, that's technically not correct. That's just me being easy on you all. Okay, it's like it's greater than, yeah. Okay, so how do you write it says, just erase this part here, we don't need that. Write the relation to as a set of ordered pairs. So relation to, we want to write so we're going to open up our set with set brackets. Now remember ordered pairs? How do we write our ordered pair? Your x comma your y. X comma y. Okay, what's our first order pair in relation to? Watermelon is associated with red. So we're going to write watermelon, comma, red. And then close our bracket. Now, between order pairs, guess what we need? A comma between each set of order pairs. What's our next order pair in relation to? Blueberries, comma, blue. Comma, blue. And then another comma, because we're going to start a new order pair. Now it's going to be cherries, comma, red. Yeah, it's letter writing, sorry. Normally they're numbers, so it's really quick. Next guy. Banana, comma, yellow. And last, strawberries, comma, red. Now if we had to write out, close your set brackets. If we had to write out the order pairs also for relation 1, how would it be different? The red would be in front. It would just be switched. Red, comma, watermelon. Blue, comma, blueberry. Yeah. All right. What is the domain and range for relation 1? So how do we write domain and range? Well, domain and range is a set. So domain is all the elements in the first set. So what are all the elements in the first set of relation 1? Red, blue, yellow. Now, red happens 3 times. Do I have to write it 3 times? No, you only have to write it once. So even though red is associated more than once, you only have to write each one. It only has to show up once. So red, comma, blue, comma, yellow. So then what's the range of the second set then? All the fruit. Watermelon, blueberries, cherries, bananas. Let's make a great fruit salad. And strawberries. And then close our set brackets. Whew. Now, the most important question is the last one. Best for last. Let's review. It says, what relation is a function? Well, what's the definition of a function? In simple terms. Each element in which? The domain has only one range. So every x has only one y. Each input has only one put. Or each color should have only one fruit. Or each fruit should have only one color. So which one of these? Relation 2 is a function. Because each fruit has only one color. See, relation 1 is not a function because the input of red has 3 different outputs. Got it? Red outputs what? It's like a vending machine, right? It should have only one output. You put your code in, one thing pops out, not 3 different things. That's not the way it works. Yeah, you'd all like that, wouldn't you? Okay, so which one's a function? Relation to. And why is it? Because it's like a vending machine, okay? Let's expand on why it's like a vending machine. There's only one. Close. There's only one output for each. So what's our, for each input? So there is only one. What's our output in this case? In relation to? What's our output? No, more specifically, color. So there is only one color. That's our output for each what? Fruit, which is our? No. X is the input. There's only one color for each fruit. There's only one color for each fruit. Okay. So tomorrow we're going to catch up on the rest of this lesson and try and attempt part of 3. So tomorrow you might have 2 homework assignments. So if you're feeling lucky and just got time tonight, I feel like you got it, then you could try lesson 2 homework as well. Okay? But your homework for tonight is just going to be lesson 1. And there'll be a quiz on that. Make sure you have a study sheet. So we have about 20 minutes left. It's a really short assignment. If you apply yourself, you maybe even finish in class.